For thousands of years, time was thought to be so mysterious that no one could ever fathom it. No one, that is, but God. He could understand it. He could control it. He could even move through time at will, seeing the future before it happened, and changing the past if he chose to. God was so good at controlling time, he even managed to fit it in between his other jobs. For humans, though, time seemed impossible to understand.
Time is the most mysterious object in the universe. You can't see it, you can't smell it, you can't touch it, yet it's everywhere. That's the paradox of time.
We feel it in here. It's something that is part of our souls, and any attempt to study time, to try to understand time, brings bafflement.
Is the me that existed when I was a child the same me that exists now? And do the things in the future already exist in some sense? That sort of question has been around from the beginning.
Time was so mysterious, scientists decided someone else should take charge of it. Someone other than God. Someone quite a lot like them.
Scientists have long had a dream, and that dream is to be a master of time, to be able to speed it up and slow it down and perhaps even stop time itself.
The dream of time travel, what would it allow us to do? We could obviously go into the past and see what had actually occurred back then. We could also effectively go into the future and see what our ultimate destiny was. This question we could answer if we had time travel, because we could go to the ultimate future and then return to the present with the answer.
The quest to find a way to master time would take science on an adventure, deeper and deeper into strangeness, and lead to a series of dark discoveries, each one more troubling than the last. The first revelation came with strings attached. Meet Sir Isaac Newton. The first attempt to understand time systematically began with him. His work astonished his contemporaries. They were less keen, though, on the starring role he gave to marionettes.
Newton's work was absolutely revolutionary. Before Newton, there was superstition and magic. After Newton, we had 3 laws of motion and the laws of gravitation.
Newton studied time for 30 years, until finally he announced he'd made sense of it. The universe, he said, was like a giant clock. Time kept everything in order.
He had the idea that there was simply one universal absolute time, the same for everybody, everywhere. Didn't matter where they were, it was the same throughout the universe.
According to Newton, time was fixed, and its flow and pace never varied. So far, so good. All this sounded rather sensible. But what followed didn't, for Newton had a dark vision about time. He said time was so fixed, so ordered, that it must have all been planned from the beginning. Our future was already decided upon, and there was nothing we could do about it.
There was a philosophical downside to Newton's laws also. The future was predetermined. We're nothing but puppets reading from the script, reading from the book of destiny.
We like to think that what we're going to do tomorrow is undetermined except by what we decide to do. But in the Newtonian view, our detailed action tomorrow was determined in the beginning of time.
Newton's ideas were so influential, they dominated science for 200 years. It was going to take something big to overturn them. Something very big indeed.
2, 1.
Einstein's work is powerful, baffling stuff.
This explosion is one of the most beautiful sights ever seen by man.
It did, however, lead directly to the nuclear bomb, which is a pretty convincing argument against those who think it is so strange it just can't be true. His impact on our ideas about time was almost as devastating.
It effectively demolished 200 years of understanding about the nature of space and time.
Einstein's theory is like a Trojan horse. On the surface, it is magnificent, it is beautiful, but inside that Trojan horse lurks goblins and demons.
Newton had said there was just one time, and there was therefore just one now. Einstein, however, begged to differ. He said time was much weirder than that. It was just like space. Every bit of space exists right now, and so every bit of time exists now too. Somewhere in the universe, your descendants are already alive. Somewhere else, your long-dead ancestors are still living. The future and the past are out there, waiting for us. And Einstein even suggested a way to get there. He suggested the answer was all to do with speed. Until Einstein, it was thought time flowed at the same pace everywhere. But he showed that wasn't so. The pace of time can change. It differs depending on the speed you're travelling at. Bizarre as it may seem, the faster you travel, the slower time will run for you.
Einstein's work completely transformed our view of time. He showed that time was bendable. All clocks did not tick at the same rate. If a clock was moving rapidly near the speed of light, it would tick very slowly.
Time is relative. The faster you move, the slower time beats. And in fact, a clock at the top of a building actually runs a little bit faster than a clock at the bottom of a building. And for God's sake, near the surface of a neutron star, or even at the center of a black hole, time slows down and perhaps even stops.
Einstein knew his theory had an astonishing implication. If time could be made to speed up or slow down, then that means it could be manipulated and controlled. You could use that effect to leave your own time behind and go to someone else's. Time travel was possible. It's easy to dismiss time travel as a fantasy, but the reason it's taken seriously at all is because it already happens. There are fully certified time travelers, and they use Einstein's predictions to do it. People like the cosmonauts on the Mir space station, for example.
The greatest time traveler so far is an astronaut, cosmonaut named Sergei Avdeyev, who spent 748 days aboard the Mir space station, traveling over 17,000 miles per hour. And when he came back, because of this, he had aged a 50th of a second less than he would have if he'd stayed home. In other words, when he got back to the Earth, he found it to be a 50th of a second to the future of where he expected it to be. He has time traveled a 50th of a second into the future.
Admittedly, a 50th of a second may not sound dramatic, But the cosmonauts of Mir could have travelled much further into the future. All they'd have needed to do was travel even faster.
Imagine I go off in a rocket ship at very close to the speed of light, and perhaps I'm gone for about a year, whizzing around our part of the galaxy, and I come back to Earth and I find that you're 10 years older. I've been away 1 year, but 10 years have elapsed here on Earth. And so, in effect, I've jumped 9 years into your future.
This sounds like an extremely weird and unbelievable property of nature. It's actually one of the best corroborated physical effects that we know of. People who build satellites have to routinely take into account the fact that time travels at a different speed in different states of motion.
When Einstein first revealed this effect, people were captivated. It seemed as if humans might master time at last. We would be able to travel through time at will. But disappointment, though, soon set in. For Einstein said his type of time travel was strictly limited. You could go forward to the future, but you could never return to your own time. Which means, if you travelled far into the future and then came back to Earth, the people you left behind and all your loved ones would be much more old or much more dead. There was a reason you couldn't return to your own time. That would require travelling back in time. And that was something which Einstein would not countenance. It was taboo, for it broke one of the greatest rules in physics. To make time slow down, you have to travel fast. But Einstein said to travel back in time, you'd have to travel really, really, really fast. In fact, you'd have to travel faster than the speed of light. Unfortunately, Einstein had also proved you just couldn't do that.
Einstein showed that if you could travel faster than light, you could even go back in time. The trouble was that Einstein also showed that you couldn't build a rocket ship that would travel faster than the speed of light.
If by some magic you could travel faster than light, then that could take you back in time. But travel faster than light was strictly proscribed. There was no way you could do it.
This was Einstein's golden rule, and it seemed to make time travel to the past utterly impossible. Some people, however, refused to accept the golden rule. They would devise outrageous schemes to get round it, and they would find a way. But first, though, they'd have to sacrifice something important, something called common sense. In our everyday lives, we tend to think common sense is useful. Physicists, though, have long been more skeptical. The universe, it just so happens, is much too upmarket and exotic for our common sense.
The universe consists of stars, supernovas, or the freezing cold of outer space. That's the universe of Einstein, with time speeding up and time slowing down. We are the oddballs. We are the exception.
Check it out, check it out, check it out. Shoot the freaking head. 15 shots, $5, 35 shots a set. Anybody can play this game.
That's why our intuition, our common sense fails us when we want to understand the universe. Some people complain that we physicists keep coming up with weirder and weirder concepts. The reason is we are actually getting closer and closer to the truth. So if we physicists keep coming up with crazier and crazier ideas, that's because that's the way the universe really is.
The universe is crazier than any of us really expected.
The question, then, is whether the universe is crazy enough to allow us to travel through time at will, to break Einstein's golden rule and travel to the past. Some people think it is. It's long been claimed that if people could travel through time at will, then we'd be surrounded by tourists from the future. But how do we know we aren't? In the United States, there are a number of people who claim to have travelled in time. And they do it quite happily in both directions.
How many time travels? I think there are probably thousands. I think it's quite possible that there are thousands of people that are doing this.
Patricia Ress has written a number of books about real-life time travellers.
12.5-foot ceiling.
There's two types of technology that go into time travel. One is the nuts and bolts, where you would get into a machine and dial and say you want to go to a certain year and a certain place, and the machine would take you. And it would work something like Star Trek, where you would disassemble and then be reassembled at a different location. The other type of time travel, it's possible to use your mind to go through time portals.
And his father's dream.
I've never time traveled because I might wander into a situation that I wouldn't have the knowledge to deal with. For example, if I ran into a dinosaur, I don't know how I would kill it or capture it. And if I went ahead in the future and had a robot after me, I don't know what I would do about that.
New Orleans seems somehow appropriate for Patricia's research. A city which feels like it might be on the edge of one of her time portals. She's here to meet a voyager in time. Called Aggie, he claims to have his very own time machine.
In the beginning, when I was working with this machine, I couldn't get anything to happen. But after I started manipulating my brainwave pattern at the same time, I started getting flashes of light coming from the side into my field of vision. And I found myself walking down the street. And I walked up to a newspaper stand. And I picked up a newspaper. And I was able to read that newspaper, and that newspaper was 6 months into the future. Some of the things that I saw in the future is very hard to believe. This country is in for some hard times. From about the fall of 2004, the stock market and the economy of this country is starting to take a dive. A year later, in about the fall of 2005, it gets to the point where we almost have an armed uprising. The military will have to step in and create order and install a new government.
So how does his time machine work? Aggie agreed to demonstrate it.
And I will plug it in now. And here is the electromagnet. And this is the time coil. And then we have the electronic box with a chip in it, the stick plate, and the dials for the fine-tuning of the frequency itself. The time coil is put around your head. It goes right over here, right above your eyebrows, around the middle of the head. Then I will bring my brainwave frequency down into the bottom of the alpha range and picture the time, the date, and the place to where I want to go. This particular machine is a mind-machine interface device. Without the mind, I doubt it will work. I can feel the machine working because the magnet is really hot, and I can feel a tingling right here in my solar plexus from the direction of the brunt of the magnetic field.
Is it working yet?
This time, no, I've been talking too much. I don't expect anything to happen here.
If Augie had travelled into the future and then back, he'd have proven it was possible to break Einstein's golden rule, the one that said travel back in time was impossible. His failure, though, doesn't mean that the rule is safe. There are other people who say they can get round it. Serious scientists. But their ideas make those of Augie seem positively mundane. The man who found a way round Einstein's golden rule was a friend of his. He also happened to be one of the most eccentric figures in the history of science, which is saying something. Kurt Gödel spent most of his life convinced he was being followed, and that there was a conspiracy to poison him. He was also one of the most brilliant mathematicians ever to have lived.
In 1949, a bombshell was dropped.
Einstein's friend, Kurt Gödel, who was one of the most famous mathematicians of the 20th century, found a solution to Einstein's equations where time travel to the past was possible.
Soon after he met Einstein, Gödel became obsessed with time travel, and in particular the limits Einstein had placed on it. Initially, he spent some time testing the idea that nothing could travel faster than light. But it turned out Einstein was right. So Gödel decided to find another way to get to the past. He changed the nature of time itself. The problem, he realized, was that everyone assumed time flowed in a straight line. But what if it didn't? What if time could loop round, like eddies in water? Gödel suggested if you could make time loop round like that, then you could reach the past. You wouldn't need to travel faster than the speed of light. You'd be able to take a shortcut and magically get there before the light did. There was only one way Gödel could think of to make time loop. It was to make everything else loop too. The universe would have to spin round.
In Gödel's universe, if you stood absolutely still and weren't dizzy, you would find that the stars and galaxies in the universe would be twirling around you. And you would find that if you went on a long enough trip away from home, you could come back even before you started.
Gödel found that in such a rotating universe, not only could an observer go off on a trajectory and reach any given point in space they liked, they could also reach any given point in time. It would be possible to leave Earth in a spaceship and travel not only anywhere, but anywhen too.
Gödel's idea of looping time was astonishing and breathtaking. It was also complete nonsense, for the universe we live in does not rotate. This, however, didn't seem to matter, for his idea made sense mathematically, and so that meant it was inspirational.
Gödel's solution of 1949 opened up a Pandora's box.
It broke the ice, or perhaps the taboo.
The genie was out of the bottle.
Gödel was to inspire a whole new generation of physicists. And even the fact that he took to wearing a balaclava all the time wasn't to put them off. here we are back in New Orleans, the home of Mardi Gras, voodoo, and by sheer coincidence, an internationally famous pioneer of time travel. And we're not talking about Aggie. Professor Frank Tipler has become the guru of all serious scientific time travelers. The first to take Gödel's brilliant but crazy solution and turn it into something almost practical.
I have always been interested in extending human power. That has been my motivation since kindergarten. I have a vivid memory of myself imagining rockets going up in the distance, which I myself had designed. Ever since, I have been interested in space travel and time travel.
In the early 1970s, he heard about the work of Kurt Gödel, and it set him thinking.
Kurt Gödel had shown that if the universe happened to be rotating sufficiently rapidly, it could give rise to time travel. And I thought this was a fascinating idea. Unfortunately, we could not rotate the entire universe. It's not now rotating, it will never rotate. But I wondered to myself, would it be possible to rotate a smaller object that might yield the same property of time travel?
The first, smaller object Tipler studied was smaller than the entire universe, but it wasn't exactly tiny. He wondered whether he could exploit the strange, vast phenomena called black holes. They are spinning regions of the universe left by the collapse of stars. In black holes, the normal laws of physics seem to have been reversed. And it had been suggested that if you entered one, you might experience time running backwards to the past. However, Frank found a rather practical problem with black holes.
The problem with a black hole is it's surrounded by a surface so that if you go inside the black hole, you can never get out again.
So if a black hole couldn't be a time machine, Tipler thought perhaps he could do the next best thing. He could make a black hole all of his own. He used mathematical equations to try and devise different rotating structures which would create the properties of a black hole without the disadvantages. There seemed to be just one structure which did the trick.
Now, it occurred to me that another rotating body, which would not have the surface of a black hole, is a long extended cylinder. I was able to prove that inevitably, if you were to spin up a cylinder sufficiently rapidly, it would necessarily have a region around it that would permit time travel, permit you to go around the cylinder and return to your starting point far away from the cylinder before you left. True time travel.
It had taken Tipler 2 years to work out the mathematical implications of this bizarre structure. Finally, he was able to announce it really would work. If you travelled round the cylinder, you could go back in time. The universe wouldn't be rotating as Gödel suggested, but the effect would be the same.
I was so excited because I thought that it had at long last shown that time travel would be, in some point in the future, within human grasp.
Frank Tipler had proved that a time machine might one day be built. The dream of moving around time at will, it seemed, could be achieved. humans would be able to go to the future or the past and return to the present day. And now others set out to build variations on Tipler's theme.
We now have a zoology of time machines. All these solutions that have been proposed for time machines do the same thing that Gödel did back in 1949, and that is warp and twist the fabric of space and time so much that space turns into time, time turns into space, and you could literally go forwards in time until you come backwards in time.
In this zoo, there is a place for almost everything, even a pizza.
Now you might wonder what pizza has to do with physics.
Richard Gott brought two very disparate parts of the universe together, pizzas and time machines.
This is time travel to the past. This is a time machine.
It all started when physicists all over the world began investigating a curious phenomenon.
In the mid-1980s, people became interested in cosmic strings. These were, I brought one here. These were thin strands of energy left over after the Big Bang that were predicted in about half the theories of particle physics at the time. They were narrower than an atomic nucleus. They had no ends, so either they were infinite in extent or they were large loops. These might be millions or billions of light years across, but very, very thin.
Perhaps, and perhaps not. In fact, cosmic strings have never been observed in the real world. They're entirely theoretical. They're mathematical inventions. So imaginary, in fact, that no one could find a way to describe them completely. Gott made his name by solving that particular problem.
I was quite excited to find this solution, and it was important to have an exact solution because it gives us a way to look for the cosmic strings.
His solution showed that space and time round a cosmic string were very strange indeed. And now he wondered what would happen with an even more exotic phenomenon. Two cosmic strings passing in the night.
Years later, I found a solution for two moving cosmic strings. And here's, if you have two moving cosmic strings that are moving by each other, what does that solution look like?
Gott's mathematical equations predict that two cosmic strings would twist time out of shape completely. There would be a loop in time, just like the one in Tipler's cylinder.
If the cosmic strings moved rapidly enough, but still slower than the speed of light. The solution was sufficiently twisted so that you could start here, circle the two cosmic strings while they were passing, and come back to an event in your own past.
And if that's not entirely clear, then here comes the pizza again.
Now you might wonder what pizza has to do with physics. Well, if you wondered what the space around a cosmic string might look like, you might think that the string would come down through the center and the space around it would look like just a regular pizza. But actually, my solution, surprisingly, showed that it looked like a pizza with a slice missing. So I'm just going to cut out a slice here and get rid of it. You can eat it if you like. And then you fold the pizza up to make a cone. And the circumference around the string is less than you might think. So this is what the geometry around a single cosmic string looks like. So if there's a second string here, you take out a second slice of pizza here, and then this is folded up on both sides. It looks kind of like a paper boat. Now, how does this make a time machine? Well, suppose you're living over here on planet A. You get a spaceship. You could send a light signal to a friend of yours on planet B, go right through between the two cosmic strings. But you could get in your spaceship, and by jumping across this missing pizza slice, you could take a shortcut and get to planet B quicker than the light beam. You can leave planet B at noon here and travel over here and arrive back at planet A at noon. In fact, you can arrive back in time to shake hands with your younger self and wish yourself a nice trip around the cosmic string.
So that's a time machine?
So that makes a time machine.
Richard Gott's proposal is only the latest suggestion for how a time machine might work. There are now many solutions which claim to allow an astronaut to go in both directions in time. Unfortunately, though, they all suffer from a common flaw. The only society that would be clever enough to try and build such machines lies thousands of years in the future.
Civilization that has galactic power, that can play with star systems and black holes, they would be masters of space and time. However, the energy necessary to drive a time machine is far beyond anything that can be harnessed by people on the planet Earth.
The time machine that I proposed using cosmic strings, if you made that out of a loop of cosmic string and wanted to go back in time about a year, take half the mass of our galaxy. Take a loop that big.
And even if someone did manage to build these machines, they'd be of limited appeal. For they all rely on creating loops in time, and it's now been realized that loops in time have a rigid rule of their own.
All of the methods that have been discussed so far, whether it's Gott's cosmic strings or spinning black holes or any of these things, all share the property that you can't go back in time to before the time machine was built. So if someone builds one in the year 3000, they can't come back and tell us about it. We can't build a time machine now and go back and see the dinosaurs, unless, of course, some friendly aliens across the galaxy have made one hundreds of millions of years ago and would lend it to us.
Exterminate! Exterminate!
You might have thought all this meant the whole idea of time travel had come to nothing. But you'd have reckoned without the imagination of physicists. The quest for a way to master time was about to lead to the darkest conclusion of all. Around 5 years ago, a group of scientists and philosophers began arguing there might be another way to travel in time. But it wasn't a machine in space, and it wouldn't involve moving galaxies around. It would be a computer. And the pioneer of this unlikely approach was that unlikely pioneer of time machines, Professor Frank Tipler. From the 1970s, he'd been excited by a trend in computers.
People realized that processing speed of computers was increasing exponentially. Every year, every few years, every 18 months, the processing speed would double.
If this trend was to continue unabated, it would mean computers would get ever faster and ever more powerful. So much so that in the far future, a super civilization would have computers which make ours look puny.
Imagine this occurring faster and faster. If that were to occur, it would be possible to process an infinite amount of information.
It was this infinite computing power, Tipler said, which would allow a future civilization to travel in time. They'd do it using virtual reality. The images computers can create have improved hugely over the last 30 years. But many physicists believe eventually computers will be able to make virtual images which are so good they'd be indistinguishable from reality. They'd be exact copies of the real world down to the last particle.
In the distant future, simulating physical systems with very high accuracy so that they look perfectly real to the user of the virtual reality will become commonplace and trivial.
But what if a future civilization wasn't just able to create images of fictional events? What if instead they could create images of their own real past? Then they'd be able to make exact three-dimensional copies of events and places in our time. These simulations would be populated by beings identical to us. They'd feel like us. They'd have thoughts just like us. They'd even think they were us. Our future descendants could then use these images to find out about their past. They'd have a time machine, but they wouldn't need to travel to the past. They'd bring the past to them.
So imagine an advanced civilization, and suppose that I want to visit the past. It might turn out not to be possible to build a time machine and actually go back into the past. Physics might simply not permit that. There is a second way in which they could get the experience of living in the past. And that would be by creating a very detailed and realistic simulation of the past.
The notion computers might one day be used to create exact copies of the past might seem like a wild intellectual exercise. But a new generation of believers in time travel have taken the idea to its own wild intellectual conclusion. And they've pointed out that a super civilization wouldn't just make one perfect simulation of the past.
An advanced civilization would have enough computing power that even if it devoted only a tiny fraction of 1% of that computing power for just 1 second in the course of its maybe 1,000 years long existence, that would be enough to create billions and billions of ancestor simulations.
Every time science has thought it has found a way to control time, it's been forced to confront a worrying implication. This latest solution is no exception, because it too turns out to have a bitter twist. One dictated by the laws of mathematical probability. If the computer of the future is churning out billions of simulations, how do we know we are living in the original real world and not one of the billions of copies? In fact, the odds against us being real are billions to 1 against.
There would be a lot more simulated people like you than there would be original non-simulated ones. And then you gotta think, hang on, if almost everybody like me are simulated people, and just a tiny minority are non-simulated ones, then I'm probably one of the simulated ones, rather than one of the exceptional non-simulated ones. In other words, you're almost certainly living in an ancestor simulation, right now.
The better the simulation gets, the harder it will be able to tell whether or not you're in a simulation or in the real thing, whether you live in a fake universe or a real universe. And indeed the distinction between what is real and what is fake would simply evaporate away.
Inside the simulation, you can't tell any difference between the simulated environment, the virtual reality, and the real environment. In fact, this environment we now find ourselves in could be just a simulation.
300 years ago, science set out on a quest to master time, to control it. People didn't like time being controlled by a super-intelligent, superior being. We'd do it for ourselves instead. But every time we made a breakthrough, there was a downside. Now we're told we may not even be real. Instead, we may merely be part of a computer program. Our free will, as Newton suggested, is probably an illusion. And just to rub it in, we are being controlled by a super-intelligent, superior being, who is, after all, the Martine.
From the point of view of science, it's a catastrophic idea. The purpose of science is to understand reality. If we're living in virtual reality, we are forever barred from understanding nature.
Our investigation of the nature of time has led inevitably to question the nature of reality. And it would be a true irony if the culmination of this great scientific story was to undermine the very existence of the whole enterprise and indeed the existence of the rational universe.